So we're going to take a look at your quick check and just make sure that we're doing it the correct way. For number 1a, y greater than x squared, remember you should first have graphed y equals x squared, which is pretty easy to graph. If you plug in 0 and square it, you can plot 0. If you plug in 1 and square it, you get 1. If you plug in 2 and square it, you get 4. And if you use symmetry, you get the following points. Now, because it's a strict inequality, meaning it's not equal to, you should have made your parabola dashed like so. And then, since it's y greater than x squared, remember if you have a greater than sign, you have to shade above the vertex. So you should have shaded in that area there. For part B, notice you have the same equation, y equals x squared, so we really should plot the same graph, only this time it should be a solid parabola because it says it could be equal to x squared. Now, but because it's a less than inequality in this instance, you have to shade under the vertex. So you should have shaded everything under there. Now, for C and D, they both have the same equation, y equals negative x squared, which, if you think about it, is just the reflection of the other graph going downwards, meaning if you plug in 0, you still get 0. However, when you plug in 1 and square it, you really have negative 1. The negative sign stays out of the parentheses. You're not squaring the negative. So if you plug in 1, you get negative 1. If you plug in 2, you're going to have negative 4. And if you use symmetry, you have the following points there. Now notice, because the inequality does have the equal to bit on there, we're going to have to make this a solid parabola, like so. And now, because it's a greater than sign, you should have shaded above. Let's do the last one, same exact equation, so we should plot the following points. Right, this time strict inequality, so we don't want to include points on the parabola solutions. But now, because it's a less than sign, we have to shade below the vertex. So I take my marker and I just shade everything underneath. Now, if you do the following, it's really ultimately the same exact thing you just did. The only thing that should be a little bit trickier is, graphing it, because it's not quite as simple to graph as y equals x squared. Because it's in standard form, remember that whole negative b over 2a for the vertex? So it's going to be the opposite of negative 4 over 2 times the a value of 2, which turns out to be 4 over 4, which is 1. So remember, that is your x coordinate of the vertex. To get the y coordinate, you have to plug that back in. So it's going to be 2 times 1 squared, that's just going to end up being 1, minus 4 times 1, that's just going to be 4, minus 3. What is that? That's 2 minus 4, that's negative 2 minus 3 more, I think you get negative 5. So that's our vertex at 1, negative 1, 2, 3, 4, 5, and then axis of symmetry is in there. I think if you shape this, meaning if you plug in 0, you're going to get negative 3, and using symmetry you'll get that point. And I think if you plug in negative 1, you are going to get, I think, 2 times negative 1 squared is 1. And then from negative 4 times negative 1 is going to be positive 4 minus 3. What's that? 6 minus 3, you get out 3. So 1, 2, 3. You get that point for free. Using symmetry, that point should be a solid parabola. Oops, I kind of missed that point there. Not the best one. Let's try that again. And because it's a less than sign, hopefully you shade it underneath. Now, I'm going to do one next bit, and you might have freaked out if you saw this because we didn't do this in the other video, but you can graph a system of inequalities, and I'm just going to do A for you. I'm going to leave it up to you guys to do B because you guys are smart. You can do it. For A, if I have y greater than or equal to x squared minus 4, that means I have to start by graphing y equals x squared minus 4. Now I recognize that as vertex form, where the vertex is going to be 0, negative 4. So I'm going to start there at negative 1, 2, 3, 4. If you plug in 1 and square it and subtract 4, I think you get negative 3. And if you plug in 2 and square it, you get 4 minus 4, which is 0. And using symmetry, I get those coordinates. Now, because it's equal to, I'm going to make it solid. And now, since it's y greater than, I'm going to shade above the vertex in there. Now, I have to do the same thing, but for a new equation. This guy, I'm going to graph y equals negative x squared minus x plus 2. This is in standard form, so remember the whole x coordinate of the vertex is negative b over twice a. So in this case, it'll be negative 1 or minus negative 1 over 2 times a value negative 1, which is really positive 1 over negative 2. That means the x coordinate of the vertex is a fraction negative a half. To get the y coordinate, we have to plug it in. So it's going to be the opposite of negative a half squared minus negative a half plus 2. If you square negative a half, I think you get a fourth, but because there's this negative sign in front of that, you're going to have a negative a fourth. Minus negative a half is really plus a half plus 2. Now I know that if I have negative 1/4 plus 2, it's like if I had a $half, take away a quarter, I have a quarter plus 2. That means my y coordinate is 2 and 1/4 or 2.25, like that. So if I plot this vertex, negative a half and then up 2 2.25 is approximately here, where the axis of symmetry, goes in here like that. Now this guy is going to open downwards. I think if you plug in 0, you get 2. And using symmetry, I would get that point. And if I plug in 1, I'm going to get negative 1 minus 1 plus 2. I think you get 0. So if I plug in 1, I get 0. That means using symmetry, I'm going to get that point. Now, because of this inequality, I'm going to use a dashed parabola. Dash it, dash it, dash it, dash it, dash it. Now I just have to figure out where to shade for this new guy. Now, because we have a less than sign, I have to shade under this vertex. So now I'm shading under here. The final solution region is where you've shaded twice. Now, I've only shaded twice in here, under the second one and above the first one. So the final answer is that blue region that's been overlapped twice. I should have used yellow and blue maybe to make green where they overlap, but hindsight's 20/20. Anyway, I want you guys to try B now in your group, and then you guys can get a crack at the homework if there's still time. Hope this helped.